Hello students, how are you all? Welcome back to Akshar IIT Foundation classes. I am your chemistry faculty S. Mohan. Grade 7. So in this we are discussing the chapter atomic structure, right? In the previous classes we discussed about the Dalton's atomic theory, in which the main concept was atoms are indivisible, which cannot be broken. And then we have seen J. Thomson's discharge tube experiment, which was proved that atoms can be divisible by discovering the negatively charged particles called electrons. And in the last class, we also discussed about the anode rays, so which are exactly opposite to the cathode rays, right? And we also discussed about the J. Thomson's atomic model. Did you remember that, like watermelon model we discussed, right? So till there we discussed, students. Today we are going to the next synopsis, that is 5. In this, today we are going to discuss about the Rutherfords nuclear model. Rutherfords nuclear model. Alright. So let us see now Rutherford's nuclear model. So students, here in the last class we discussed about the J.J. Thomson's atomic model. So when the J.J. Thomson proposed his atomic model after discovering the electron, he expected that he did not know about the protons. So he expected that atoms are like a positively charged spheres. Atoms are what? Positively charged spheres, and in that electrons are embedded. Electrons means what? Negatively charged particles embedded. Okay. Now, then Rutherford conducted one more experiment, which is called the alpha ray scattering experiment, or which is also called a gold foil experiment, right? So Rutherford conducted one experiment which is called what? Alpha ray scattering experiment or gold foil experiment. So now let's discuss about the alpha ray scattering experiments. So alpha ray symbol like this also you can say, students, like this, alpha. So alpha ray scattering experiment. Okay, which is also called gold foil experiment, students, which is also called what? Gold foil experiment. Okay, so now let us see what is alpha ray scattering experiment. Students, here what he has taken is, he has taken a thin gold foil. Rutherford taken one thin gold foil of about 0.01 mm thickness. What is the thickness? 0.01 mm thickness, means very thin, right? So normally you can take the scale, that scale 15 centimeter scale in the geometry box. That scale is divided to like 15 centimeters. So each centimeter is divided to millimeters. The small lines are there, right? That millimeter, if you divide it into 100 parts, the small gap, if you divide into 100 parts, what you will get? That is equal to 0.01 mm, right? So Rutherford taken one gold foil. So that is a gold foil. Here I will write the gold foil like how. Okay, let's take. So this is a gold foil. What it is? A gold foil. Means what? Thin gold plate or foil. Okay. Now here he has taken alpha particles. Means one radioactive element in one box. So here this is, let you take one lead cavity, means what, lead, one box, lead box, and in this he has taken some radioactive material. What is the material? Radioactive. This material is called radioactive material. Radioactive material. Radioactive material means what? Which emits the alpha particles. Which emits what? Alpha particles. Acha, before that, let us see what is meant by the alpha particle. Students, here alpha particle is made up of 2 protons and 2 neutrons. Alpha particle is considered as the helium nucleus. Already we discussed the hydrogen, helium, lithium, beryllium, boron and so on. In the second element is what? Helium, right? So helium. Helium atomic number is what? 2, right? So this helium consists of 2 protons, 2 neutrons and 2 electrons, right? 2 protons, 2 neutrons and 2 electrons. Now in this, these 2 protons and neutrons are present in the nucleus. Where they are present? This present in the nucleus. 2 protons plus 2 neutrons are present in the nucleus. Nucleus means what? A very small region. Actually now I am going to explain you. So there is a nucleus and electrons will be revolving around the nucleus. 2 electrons will be there. The 2 electrons will be revolving around the nucleus. Okay, like this 2 electrons are revolving. Now if you remove the 2 electrons, from the helium, then what is left now? Only nucleus is left. Like this nucleus is left. That is what? Helium nucleus. So helium nucleus consists of what? 2 protons and 2 neutrons. And 2 protons means what? Each proton carries 1 unit of positive charge. So this consists of 2 units of positive charge. And neutrons also there, but there is no charge for the neutron. Okay. So the meaning is what? Overall, alpha particles are doubly positively charged particles. What are they? Doubly. Doubly means what? Double. Okay, twice. Okay. So 2 units of positively charged charge carrying particles. These are the alpha particles. Okay. So remember, that is alpha particle. I am rubbing. This is not required to you. So just you have to understand that alpha particle is nothing but which consists of 2 protons and 2 neutrons, and their charge is +2 and their mass is +4. 4 mu. Okay. So you have to remember that. So these are radioactive material. Now actually the arrangement will be different. So here arrangement, if you see here, he arranged one slit also. Here slit means what? A small gap where the electrons will flow only in single direction. Okay, like this. Okay, and then he arranged one screen here around it. This is called as a fluorescent screen. What is called? Fluorescent screen. Like this screen is arranged. That is called a fluorescent screen. What is a fluorescent screen? Or the zinc screen which is coated with the zinc sulfide. Alright. So here this is the arrangement of the Rutherford alpha ray scattering experiment. Right. So here this is a source of radioactive material. So there is a source of alpha particles that is emitting the alpha particles. Right. Now these alpha particles are positively charged. So these alpha particles are released from this material and they pass straight like this through this slit. A small gap is there. So through this slit, straight they are moving and they strike to the gold foil. Okay. In the path of that, he arranged one gold foil, thin gold foil. Then what happens? These particles will strike to the gold foil. Right? If the particles penetrates means what? Passing through the material. Penetrates through the gold foil, then they strike to this screen. When they strike to the screen, they form the sparks on it. What they form? Spark, which are called scintillations. Okay, so like this he arranged. Now from here, He passed the alpha particles here like this, alpha particles. Okay, and alpha particles are passing straight like this here. So alpha particles are passing straight. After passing straight, what happened now? After striking to this, okay, they are striking to the gold foil. And it was Rutherford observed that after striking to the gold foil, most of the alpha particles are penetrated. Penetrated means what? Passed through the gold foil. Okay. So then he observed that most of the alpha particles are passing straight, okay, through the gold foil like this. Okay, and very few particles are deflected also like this, and very few particles they deflected more than 90 degrees, and one out of almost 20,000 particles rebounced back also. Okay, rebounced back. So this is the alpha ray scattering experiment. This is what? Alpha ray scattering experiment. So alpha ray scattering experiment is what? So this is a gold foil, and this is a radioactive material which is the source of alpha particles. Alpha particles are what? These are the doubly ionized helium nucleus. The meaning is water. Here they consist of 2 units of positively charged particles, and these particles will passed, okay, through this one. So they are striking to the gold foil, and most of the particles are penetrated. Penetrated means passed through the, after striking, they are passing through the material. Okay, so through the gold foil. Okay, and they are striking straight on the screen. Clear to you? Sorry, students, little cough I am suffering with. So, right. So this is the experiment was conducted with the gold foil. Now, after this experiment, he made some observations. What are those observations? Now let us see what are the observations here. Okay. So let's see the observations of the Rutherford experiment. Observations. So what he made the observations? Here in the J. Thomson he said that atoms are like spherical in shape, which is positively charged sphere in which electrons are embedded, right? If it is like that, if according to J. Thomson what he said, atom is a spherical, okay, here I am drawing rough diagram. So this is a positively charged sphere. What it is? Positively charged sphere means total positive charge is there, okay, and in this electrons are embedded, means electrons are present in that, right? Electrons are embedded like this, electrons are embedded. Sorry, that is the Rutherford atomic model, sorry, Thomson's atomic model. So this red color is what? Total positive charge. This is a positive charge sphere. Here Rutherford is passing what? Alpha particle. Alpha particle is what? Positively charged particle. Alpha particle is what? Positively charged particle. If the positively charged particles comes like this towards the atom, okay, towards the atom, then these are the positively charged particle. This sphere is also positively charged, right? You know, I think that like charges repel and unlike charges attracts. Yes or no? Like charges repel, unlike charges attracts. Do you know this one? Example, you take the two magnets. Example, okay, magnet will have the two poles. One is north pole and second is the south pole, right? Now, for example, I have the two magnets. Let's imagine these are the two magnets. These are the two magnets, right? So now red one which is there, this is the north pole you think, and this other end which is there, this end is the south pole. This is the north pole, these are the south pole. Now, if you bring two north poles like this, does they attract? No, they repel. if you place like this one magnet and facing the north pole this side, and take the another magnet with the north pole and make this north pole to move towards the north, then what happens? This other magnet will move back. Yes or no? As you are moving towards it one, this will move back, because that both are repel with each other, because these both are like poles. Now similarly, if you bring this side like this, now if you bring, then immediately they will attract. Sorry, north and south attract. Okay, north repel and south repel. So like charges repel, unlike charges attracts. This you know. So here, according to J. Thomson, atom is a positively charged sphere, and Rutherford passed the positive charge particles only, that alpha particles. Then what should happen? The like charges should repel. Okay, so these particles should not pass through the this atom, means what, through the gold foil, but they should deflect like this. Okay, why? Because these are also positive, that is also positive, right? Right. So due to repulsion forces, but here what he observed is most of the alpha particles are passing through the material, means what, passing through the atom. Okay, so his observations are that, first observation is that most of the particles, most of alpha particles are are penetrating, are passing, alright, are passing through gold foil. Most of the alpha particles are passing through the gold foil. You can't understand, no? I read little bit neat. Writing is not good here. Okay, so most of alpha particles, okay, passes through gold foil. I am short writing GF, gold foil. Okay, so most of the alpha particles are passing through the gold foil, right? That's the first thing. Then what he observed here, see few rays, few particles are deflecting, few particles are deflecting. Okay, so you observe that few particles, few alpha particles, okay, are deflected with the different angles. Okay, you observe that few particles are deflected with the different angles. And third point, what is said here, what he observed is 1 out of 20,000 particles, 1 out of 20,000 almost alpha particles is rebounding. If we passed 20,000 particles, then one particle, most of the particles are passing through, only one particle is rebounding back. So almost 1 out of 20,000 approximately, 20,000. This is not exact figure, just okay, particles are rebounding back. These are the observations were made by the Rutherford. Okay, so Rutherford observed that most of the alpha particles are passing through the gold foil. Second, on few alpha particles are deflected with the different angles, and 1 out of 20,000 particles means very less particle. 1 out of 20,000 particles is rebounding back. How is it moving? The same way it's rebounding back. Clear? Okay. So these are the observations of Rutherford. So he observed these things from this experiment. Clear? Okay. Now after this observation, what he concluded? Okay. So he concluded that most of the alpha particles are passing straight. The meaning is what? Most of the space in the atom is empty. What he concluded? Most of the rays are passing straight through this one. So the meaning is what? Most of the space in the atom is empty, means khali. Okay, so that's what the easily these alpha particles are passing through it. Okay, and few rays are deflected and 1 out of 20,000 particles are rebouncing back. Then observe that here this one particle is rebounced back. So this is rebouncing because of just how I told you, like charges repel, unlike charges attracts. So here few particles also deflecting, that is due to repulsion only, due to repulsion, and one particle is completely rebouncing, that is due to repulsion. And here there is a positive charge repel with a positive charge only, right? So then he said that what he concluded that if you take an atom at the center of the atom, there is a small region is there, okay, and in that small region this total positive charge and mass of an atom is concentrated. Okay, so what he expected? He expected that. So here, see here, can you see the diagram here? Okay, I'll draw the diagram here. Okay, so see here, for example, if it is atom like this, okay, this is an atom. Then what he concluded that most of the alpha particles are passing straight, means like this. You see here. Here I am taking single atom now. For example, I am taking single atom. Okay, so single atom. See, most of the alpha particles are passing through that gold foil. Right. Now see here, few particles are deflected like this. Right. Very few particles, or 1 out of 20,000 particle, is rebouncing back. How it is going in the same direction? It's coming back. The meaning is what? The total space, most of the space is empty, but here only it is coming back. Means what? Here there is one small region is there. What is that? There is a small region at the very center of the atom. At the very center of the atom, there is very small region is there. Okay, where the total positive charge and almost the total mass of an atom is concentrated. Clear to you? So where the total positive charge, not like this. Here he said that Thomson, what he said, the positive charge is totally distributed with the atom. Total atom. No. Here positive charge is present only at very center, very small region at the center, only present or concentrated. Okay. So at the center. And he gave the name to this one, that center region is called nucleus. Okay. So, based on his observations, Rutherford proposed one atomic model, and in this atomic model, he proposed some important features, some postulates. Now, let us see what the postulate. First postulate is what? Atoms are spherical in shape, and most of the space in the atom is empty. Okay, that already we discussed now. Okay, now let's come to the second one. What second point is that? The total positive charge, okay, and almost mass of an atom is concentrated in a small region at the center of atom. Okay, so the total positive charge and almost total mass of an atom are concentrated at the center of an atom, and this is called nucleus. What is called? Nucleus. This is a very important point. Nucleus. Okay. Now what is the third point? Nucleus. So this is a nucleus where total positive charge and the total mass is situated. Right. Now that's what that's what this model is called as a Rutherford's nuclear model. Now what the third point states? Third point states that Now see, he explained about the positive charge, but electrons are already discovered with the J. Thomson. Then what about the electrons? So he said that electrons. Third point he explains about the electrons. Okay, electrons revolve around the nucleus. Around the nucleus, like planets revolve around the sun. Okay, like planets around the sun. Okay, so you know that sun is a star which is present in the center of the solar system, and the planets all revolving around the sun. How the planets revolving around the sun? Similarly, electrons revolve around the nucleus. Okay, that's what the Rutherford model is also called as a planetary model. What it's called a planetary model, right? So that's about the postulates of the Rutherford atomic model. And one more important thing is that Rutherford also could able to calculate the size of an atom. The size of an atom. And Rutherford observed that the size of an atom, okay, the size of an atom, okay, the size of an atom okay, in terms is equal to, or we can say that approximately 10 to the power of minus 8 centimeters or 10 to the power of minus 10 meters. This was the size of an atom. And he said that size of the nucleus, the size of the nucleus, size of the nucleus is 1 lakh part. Is how much? 1 lakh part. The meaning is what? 10 to the power of minus 13. Okay, centimeter or 10 to the power of minus 15 meters. Okay, so this is the size of the nucleus, right? And here, how can you compare means? For example, if you think, if you think football stadium, if you think football stadium, the size of the football stadium, if you compare with the size of an atom, if you compare with the size of an atom, then the size of the nucleus, okay, the size of an atom, the size of an atom, this part, the size of an atom, if you compare with the football stadium. So I think this is a football stadium. Then the size of the nucleus is equal to the size of the football. The size of the nucleus is equal to the size of the football. Means what? This is nucleus, no? So this nucleus size is like a football in the football stadium. So such a smaller region, okay, is the nucleus. Clear, students? Yeah. But here there is one drawback is there. That one drawback we discuss and we'll stop the class today. The drawback is that here he said that electrons will be revolving around the nucleus. Right? Electrons revolve around the nucleus, he said. But electron is what? A charged particle. Electron is what? Charged particle. According to the classical laws of physics, there were some laws of them which are called as the classical laws of physics. According to the classical laws of physics, any charged particle in motion, then it emits out the energy. It emits out what? It loses or it radiates the energy. The meaning is what? For example, if you think this is a nucleus. If you think this is a nucleus of an atom. Okay, and electron is revolving. Electron is revolving like this, you think. So the electron is revolving like that. Okay, then according to classical laws of physics, according to classical laws of physics, any charged particle, if it is moving or it's accelerating, then it radiates its energy. So if it is moving, it radiates its energy. When it radiates its energy, then its energy becomes less. Right? When its energy becomes less, then that will be under the influence of the nucleus. So then it will be attracted towards the nucleus. If it is attracted towards the nucleus, then what happens? It comes closer to the nucleus and finally it falls in the nucleus. where it falls? It should fall in the nucleus. So, did you understand what I said? Electron is a charged particle. If any charged particle is accelerating or revolving, then it radiates its energy. Radiating means what? It releasing, emitting the energy. Where it's emitting the energy, then it losing, the meaning is what? It losing its energy. When it's losing its energy will be decreases. So it is attracted towards the nucleus. When it's attracted to the nucleus, then it comes closer to the nucleus and finally it falls in the nucleus. When it falls in the nucleus, then atom should collapse. Atom should what happen? Collapse. If atom is collapsed, then there is no matter, because any matter is made up of a tiny particles called as atoms. If atom is getting collapsed, then how the matter forms? So there is no question of matter, right? But matter is existing all around us. Meaning is, meaning is what? Atoms are not collapsing, they are stable, right? So the meaning is what? Rutherford could not explain. Rutherford could not explain the stability of an atom. What he could not explain? He could not explain the stability of an atom. So that is a drawback. Simply you can say that Rutherford could not explain the stability of an atom. Okay. So that's all, students. So with this, today's topic is done. Okay. Today's topic is very important, atomic structure. That is, in this we are discussing the Rutherford atomic model. So Rutherford atomic model, Rutherford conducted alpha scattering experiment. Based on that, he observed that most of the alpha particles are passing state. The meaning is what? Most of the space in the atom is empty. So based on that, he proposed atomic model. So that is about the Rutherford atomic model. So students, with this we stop today, and we'll meet in the next class. Till then, bye, take care and study well, read, right? And today, some disturb due to cough, so sorry for that. Okay, bye.